Today we are going to simplify complex rational expressions. Now you may ask yourself, what is a complex fraction? Well, a complex fraction is when there is a fraction in the numerator, one in the denominator, or one in both the numerator and the denominator. But before we get into this, I want you to look at the bottom of your screen, and you're going to see a review problem from what we learned last class period. Go ahead and pause it and work through that question. Now that you've looked through that question, this is what you should see. This was what you should have done. You should have looked at the denominators and saw if they factored. Well, yes, this does factor in the x plus 4, x minus 1. This does not factor. Now you have to find a common denominator. So you looked and saw, you saw x plus 4 here. X minus 1, you don't see an x minus 1 here. So that tells you you're going to multiply the top and the bottom right here by x minus 1. So, in doing that, let's go ahead and begin simplifying this sum. So, let's find our common denominator, which we already found, and let's put it all under one common denominator. So I'm going to have an x plus 4 and an x minus 1 down here. On the top, I have an x minus 3 plus 2x times the quantity x minus 1. Now, I'm going to distribute the 2 in there, so that gives me x minus 3 plus 2x to the second minus a 2x all over x plus a 4, x minus a 1. Now, from here, let's add like terms. So on the top, I'm going to end up with a 2x to the second minus x minus 3 all over top of x plus a 4 and x minus 1. Alright, let's go over to the side here and let's factor this numerator. So, if I have the 2x squared minus x minus 3, that's going to factor into 1 times 2, 2 times 1, negative 1 times 3, negative 3 times 1, and I'm looking for a negative 1 right there. Well, let's see here. If I look at this, it looks like it's going to be this one right here. Alright, so let's go ahead and factor that. We're going to see if anything divides out. So factoring this, on the top I'm going to have a 2x and a 1x minus 3 plus 1. And on the bottom, I have an x plus 4 and an x minus 1. So, looking at that, I can see it does not factor. Now, let's go up and look at the directions again. Does it want us to restrict it? And yes, it does. I see it says identify any x values for which the expression is undefined. So we're going to go back up here, and I'm going to put a comma, and I'm going to say x is not equal to, and you can look right here, and you can see if you plugged a 4 right there, I'm sorry, a negative 4 right there, you would see it be undefined. In other words, it'd make the denominator go to 0. And if you plugged a 1 right there, it would make that factor go to 0, meaning it's undefined. So you're going to say x is not equal to negative 4 and a positive 1. Alright, and there is the review from last class period. On the second slide, I went ahead and defined a complex fraction, which I stated verbally on the previous slide. So it says a complex fraction contains one or more fractions in its numerator, its denominator, or both. So here's some examples of complex fraction. Okay, looking at the first one, there's an example. Notice the fraction is in the denominator. Okay, and the second one, notice there is a fraction in the numerator. And looking at the third one, notice in this example there is a fraction in the numerator and in the denominator. Okay, now, one more thing I need to point out. You see this division bar right here? Okay, let me change that to a pointer here, and let's look at it more closely. You see that division bar right there? Or that division bar right there? Or that division bar right there? Well, that division bar acts as a parenthesis. It acts to group the denominator and the numerator together. Alright, so what I'm going to do is I'm going to write a complex fraction as a division problem. Then I'm going to simplify it. Now you may say, well, what do you mean? Write it as a division sign. Well, instead of writing it showing that division bar, I'm going to do this to it. I'm going to put, and let's rewrite it, I'm going to put x plus a 3 divided by an x, and I'm going to put an x plus a 4 divided by a 7r, and instead of stacking them on top of one another, I'm going to put a division sign in between. Now at this point you may look at it and say, oh, that looks familiar. And yes, it does. If you go back to 8-2, day 2, this is the type of problem that we did in that section. That's the type of problem we did. So in a sense, you can probably say, I already know what to do with this problem to simplify it. Here's our first example. In looking at this first example, let's read the directions first of all. It says simplify, and then it says assume that all the expressions are defined. That means you do not need to indicate what x is not equal to. Alright, so let's take a look at this first one. First of all, it says write the complex fraction as a division. In other words, you're going to put the numerator first, and then you're going to show a division symbol instead of the division bar, and then you're going to write the denominator down. Now, at this point, remember KFC? That means we're going to keep this one, we're going to flip the second one, and we are going to change the division to multiplication. Now look at this and ask yourself, is there anything in the bottom that is also in the top? And I do not. So you're just going to shove it all together, and voila, there's your answer. Now, you can either you can leave it like this, all factored out, or if you choose, you could multiply it together. If it were me, I would leave it, definitely, I would leave it like this. The only time I would ever change it from this form to this form is if the test happened to be in multiple choice, and I looked at my test answers and they were all written like this. Then I would multiply it together. For your homework tonight, just leave it like this. In this problem, the first thing you're going to do is write the complex fraction as division. So you're going to put the top fraction first. Instead of the division symbol, instead of the division bar, you're going to put the division symbol. And then you're going to put the bottom fraction, the denominator, second. Then at this point, you're going to KFC this here. So KFC it. So you're going to keep flip change, and it's going to look like this. Alright, so that means, okay, so we have step 1 was to write it as a fraction with a division symbol. Step 2, you're going to KFC it, okay? So step 2, we'll put that right there. Okay, then step 3, you're going to factor it, okay? And when you factor it, on the top, it's going to be x plus a 1 over, now that's the difference of two squares, so f minus 1 over x plus 1 times x minus 1 over x. Next, step number 4 is you're going to simplify it. So when you simplify it, you're going to divide what's common, top and bottom. So I'm going to divide this x minus 1 with this x minus 1 there. I'm going to divide this x plus 1 with the x plus 1 there. And on the top, you may say, oh, I don't have anything left. But remember, there's always a 1 left. So on the top, you're going to have 1 over, and on the bottom, all you have left is an x. So 1 over x. And that's what you should have gotten. In this slide, we're going to take a look at how we can apply what we've learned in simplifying complex fractions. So let's go ahead and read this question. In the question it says a hiker averages 1.4 miles per hour when walking downhill on a mountain trail and 0.8 miles per hour on the return trip when walking uphill. What is the hiker's average speed for their entire trip, round to the nearest tenth? Alright, so we know that a biker, first of all, starts walking down a hill. So we have a hill like this, and the little hiker is going to walk down the hill. When he walks down the hill, we don't know how far he went, so we're going to call it a d distance. At some point he stops and he starts walking up the hill, and he walks up the hill that same distance. That means his total distance walking down and walking up is d plus d, or it's going to be a 2d distance. Let me make that look a little bit more like a d here. So it's going to be a 2d distance. Alright, so with that in mind, total distance is 2d. Now, we need to reflect a little bit on a formula you guys have used quite often in Algebra 1 or possibly in your general science class, and that formula is rate times time equals distance. Now, because I need to know the total time, I am going to divide both sides by r. In other words, I get d is equal to my distance divided, sorry about that, let me put the wrong letter there. I know that t is equal to the distance divided by my rate. Okay, so now let's see if we can come up with the total time. Now, the total time here is this. Walking down the hill, the biker walked 1.4. So his total time is going to be d divided by 1.4. Walking up the hill, he walked a distance of d, and he walked at a rate of 0.8. So his time is going to be d divided by 0.8. Now, we're going to next find the average speed. Now, the formula for average speed, and I've showed it right here, it is the total distance divided by the total time. Now, remember my total distance, we already figured that was 2d. My total time, well, that's what we get when we add the distance that it took the biker to walk down the hill. The time it took the biker to walk down the hill, plus the time it took the biker to walk back up. And when you've done that, your formula looks something like this. So it's going to be 2d over d divided by 1.4 and plus d divided by 1.8. Now, from here, we need to simplify this. But you know what? In order to simplify it, I'd like to get rid of these fractions in the denominator. So I'm going to take each of these decimals and I'm going to change them to fractions. So this is going to be d divided by 7.5, and I showed it right here, d divided by 7.5. So d divided by 7 over 5 is the same as 5d over 7. Now in the second one, I have d over 0.8. Changing that to a fraction, it's d over 4/5. And then I'm going to simplify that. So when I flip this over and take d times 5/4, it gives me 5 over 4 times d. So here is what the first one is, and here's what the second decimal is. And that'll get rid of our decimals. Okay, so now compare. See this 7 and see this 4? What's the common denominator between 7 and 4? Well, you just multiply it together. 7 times 4 is 28. So what I'm going to do here is I'm going to multiply top and bottom by 28. Alright, so let's get that out of the way. So I'm going to multiply the top by 28. Okay, right here. Going to multiply both bottoms by 28, and in doing so, I make it look like this here. So I have a 56D over a 20D plus 35D. Now from here, I'm going to add like terms on the denominator. And when I add like terms, I'm going to get a 56D divided by, and when I add 20 and 35, that gives me a 55D. Now, if we plug that into our calculator, let's see, we have 56 divided by 55, and that gives us 1.018, and we're rounding it to the nearest tenth. That means it will be approximately equal to 1. So that tells me that the hiker's average speed is 1 mile per hour. Okay, folks, this pretty much wraps up simplifying rational expressions. If you would please write down this assignment. This is the assignment we're going to be working on next class period. Now, the next time we watch a video, we're going to be moving on to section 8.4. Now, 8.4 is all about graphing rational equations. So that should be fun. So make sure you bring your graphing calculator or graphing device. And if you have a device, make sure you have a GeoGraphing calculator on it or the GraphCalc Pro application. Have a good day. Goodbye.